Okay, so again, looks like we have another limacon here. Okay, only it's going to be a little different, right? Because this becomes what? 3 minus 6 sine theta, right? Okay, so it looks like we're going to have like an inner loop in there, right? So we're going to be expecting a loop. So what I would say with these inner loop ones, um, uh, I would, it's going to be 9, and your loop's going to be 3, right? So, but why don't we plot points? It might be safer. But we do know it's an inner loop, right? And let's take a look at these things. And the length will be these two added together, right? So it's inner loop, okay? So let's try these. 0, right? It's sine, so let's use our favorites, right? And there aren't any ends here, so let's just go for like pi over 6, pi over 2, right? Bring all the favorites in, all the usual suspects. Pi, right? We like that. 3 pi over 2 and 2 pi. We probably won't need all these, but let's go for this anyway. Sine of 0, right? This is theta. This is sine theta, right? What is 0? Right? Sine pi over 6 is what? Sine pi over 6 is 1/2, right? Sine pi over 2 is 1. Sine pi is 0. Sine 3 pi over 2, negative 1. And then we're back to 0. Okay, so let's look at what's going on here. Okay, so we're looking for an inner loop. Let's start out with 0, right? 0, this starts out here, right? Okay. And then what do we have? After that, we have, let's take sine of pi over 2, right? So this becomes sine of pi over 6, rather, right? So we're at 30 degrees here, right? 1/2 of this, right? So 2 times 1, 1 minus 1, right? That brings us down to 0, I believe, right? Because 2 times 1/2 is 1, right? 1 minus 1, right? 3 times 0, right? So this should bring us back down to 0 as we're pointing in this direction. Okay, this is where we're at right now. Let's bring this all up to pi over 2, right? Pi over 2 gives us 1, so 1 minus 2. 1 minus 2 is negative 1, so we have negative 3. Interesting. So we're pointing this way, we have negative 3, so we're down here, okay? So there's our negative 3. Okay, does that make sense? Yeah, so we're done these. All right, let's look at pi. Let's see where we're at with pi, okay? This is 0 again, right? So pi, we're back out here at 0, right? And let's try 3 pi over 2. Okay, 3 pi over 2 becomes negative 1. So this is where it gets interesting, right? This becomes negative 1, so this becomes, we're adding 6. So this becomes a 3 plus 6, okay? This is where the 3 plus 6. So this becomes, when we're pointing in this direction, right? When there's pointing this direction, this brings us down to 9. Now this is weird because you say, oh, hold it, we've already plotted a point, but remember, this was actually when we were doing pi over 2. It just happened to be bring us negative, so we can cross 2 places, right? So what happens? We know it's a inner loop lemniscate, right? Inner loop lemniscate means that there's going to be an inner loop, obviously, and that means that what do we have going on here? So we have a inner loop. We know it's going to simply be 3, right? Right? It's going to be 3, right? And then we know that these are going to come out and then bring the other sides of this. And that's going to bring us out to 9, right? These two added together, right? We draw that, and I think, ooh, that looks pretty darn good. Okay, so that looks like our lemniscate with the inner loop, right? And yeah, and then what else do we have going on here? Good. So, and this is 9, right? 3 plus 6, 9, right? And that all looks pretty good, right? Negative. It's symmetrical to the y-axis, but it's negative, so it's pointing down, right? We got our 9s, we got our 3s. That looks pretty much perfect to me, okay? Again, if you want a little more rigor, plot more points, okay? But that will show you, that gives you a good overview on how to handle these. Again, follow the steps, really get to know what the characteristic of each curve is. So figure out what curve it is, right? Number 1. Number 2, you know, figure out what each of these things mean, right? All these A's and B's and, you know, N's and whatnot, right? They're different for each curve. Go back and review so you're familiar with that, okay? Those things you should really commit to memory. It will help you out a lot. And then after that, if you're still confused, just plot some points. Keep in mind you're dealing with sine and cosine, so that's why you have to stick to numbers like, you know, unit circle numbers or the pi over 6s or pi over 3s. Take care that if there's a constant there, that's going to change which critical points you want to use. But I'll let you use your judgment, your understanding of trig to pick the best critical points. They're really just points to draw up, to put on here so you can, you know, connect the dots, basically, right? So it's all about connecting the dots. Okay? So anyway, that's gives an overview on how to graph these polar coordinates. Thank you again for using Educator.com.